As a 20-year-old, our guest today became the youngest person to launch a rocket that could reach space, and he actually made it happen. At 30, he built and launched the world's first 3D printed rocket that was printed on the world's largest 3D printer that his company developed. He also founded that company that is now worth $4.2 billion. His name is Jordan Noone, and he is on the podcast today. Jordan, welcome to the Business Method. How are you, my friend?
I'm doing well, Chris. I'm happy to be here.
I'm excited to have you. I don't think I mentioned this actually. We're doing a series of interviewing 100 people that have built billion-dollar companies. And the reason behind this, and we're about, I think you're number 21 or so. The reason behind this is because what I've found is that people that have built and scaled companies like this, they think very uniquely and they think differently, and they're pretty limitless with their thinking, I believe, in some respects, at least when it comes to the trade and the business that they're building. And we interviewed Alex Rodriguez, and I don't know if you
Mhm.
know him, but he's also a Y Combinator, I guess you could say alumni. And he founded with his best friend Embark Trucking, that became the largest self-driving trucking company. And he's 27 years old right now. And it was fascinating just listening to him. But as I started to research you more and read about your story, I saw some similarities that you had with Alex. Alex was diving into his passion at a very young age. He was building self-driving golf carts at 17 years old, won the world's robotics championship. You and your father were very passionate about airplanes, right? And so
Mhm.
you were diving into airplanes, aviation, aerospace since a very young age. And so maybe you could take us back to those early days because I find it very curious. Like my passion was farming and baseball when I grew up, right? And your dad sent you down a different route, which, brought you to where you are today. So if you could like take us back to that time, like what are those key memories maybe that or experiences that you had with your father that really pivoted to make you into the entrepreneur and the innovator that you are today?
Great set of questions. And for me, I think a lot of it started with Legos and building. Then I've always been a tinkerer,
Alex
and I
had the
find
same
it
thing,
fairly.
actually. Alex had Legos in his room even till this day at a 20 as a 27-year-old. So
Yeah, it'd be
maybe
good to.
for kids, get your kids into Legos.
I'd love to hear the amount of kind of entrepreneurial value that came out of doing Legos like very early. But for me, I remember very young model train sets, Legos, Connects, then kind of building and building. And it's something that I don't entirely know where my first set came from or if my parents knew that I had like a knack for it on building things. But I remember just building things with my hands since very young. And then my dad eventually started having me help out. He had an old truck. It was his dad's old truck that he was repairing. He still has it, and we would work on the engine together. We'd tear it apart. I knew very little of what I was doing. At that age, I can't remember entirely how young I was. And but that laid a foundation where I knew that I wanted to go into kind of engineering or physics, something kind of mechanical design or science, and fairly early on. And that shaped my eventual college applications, where I applied to USC as an aerospace engineer.
Did you fit in or did you do well in school? First, like public schools,
Mm.
private schools, what did you attend? Was it normal for you? Was it easy for you? What type of person were you or child were you?
I was a very difficult student, I'd
Okay.
say. Public school, South Pasadena, California, and where I was born and raised. And for me, the school structure is what I rebelled against the most. Then I generally liked kind of doing my own thing, whether that was building something or not doing anything or playing video games. Like I kind of had my path that I enjoyed, and I really did not like people telling me what to do, probably even if it was for the best, on certain classes and things like that. I had an intentional rebellion there. I don't
Yeah.
entirely know where that was rooted, but I remember, I think it was my first time not turning my homework in and getting, I can't remember what the entire kind of like what it led to the teacher doing, but I remember being sat down in like fourth or fifth grade and being told like, this will catch up to you if you don't do your work.
Right.
And I stuck with that and rebelling against kind of the school structure in most classes until late high school. I eventually realized that I had to get my act together if it was going to lead to a good college experience and career. And but probably between like fourth and 10th grade, very little homework done, very little structure that I listened to.
Yeah. And you said you were rebellious. Were you rebellious against the system? Maybe because you didn't understand it or didn't make sense to you, or rebellious because you had a deep embedded anger. You're just a frustrated child.
No, I don't think it wasn't out of anger. I think it was lack of appreciation, which I think in some ways was true of certain structures and classes being done not for my benefit. And
Yeah.
maybe the way I eventually understood it in college, and which is where I'd highlight because that rebellion carried through into the college days. It definitely didn't diminish. And if anything, it was, there were certain classes that I felt were structured in a way that was for the professor going on like an ego trip.
Yeah.
They were the expert at something and they wanted to show everyone.
Yeah.
And it wasn't necessarily for the benefit of the student
Yeah.
and the student's path. And that's something I eventually had the comprehension of the dynamics within, academia and certain professors that were not necessarily fans of the teaching. They were there for other reasons. And the students were the ones that suffered through that, where essentially it wasn't designed for the best experience and outcome for the student.
Yeah.
And that, as I became aware of, it was something where certain classes I realized if I put effort into them, then there was a disproportionate kind of range of outcomes that came out of that. And some classes you grind and grind and grind just to do homework sets. Then at the end of those, you didn't learn anything.
Right.
And some classes you do that grind and you come out and you learn something. And it's really within the design of the class, the effort of the professor to design something where the student learns something by the end of it.
Yeah.
But that led to a fairly kind of asymmetric set of interests from a lot of my peers, where certain classes that they found easy, you do a little bit of homework, you get an A.
Yeah.
For me, I got nothing out of those, or many of them I didn't, and those ones I didn't put effort into. And some classes you had to grind on, and you still learned nothing, and those I also didn't put effort into. There are certain classes where you put the effort in and you get something out of it. You learn a new skill, you learn something for life, even if that's not what interests other students or that's not where the easy A's were to get. That's where I put my effort into. And I think that had traceability back to my younger years. I just didn't understand it as much as to what was happening or why I was interested in it. Certain classes I loved and enjoyed the maths, the science, the physics side. And other classes I didn't appreciate the outcomes of those. And some of those, regrettably, I didn't understand the outcomes of those or appreciate them as much, so that I appreciate them more now. And those were the ones that I did not like people telling me, that I had to put effort into those.
Yeah. Makes sense. I think too, I think this has been spoken about so many times, especially amongst the entrepreneurial world, is that the way, schooling, the way that's structured is a bit antiquated, right? Like it's was designed for the industrial age, and we're still learning with the same systems and processes, which doesn't necessarily serve the information age that we live in. But that takes us to, you being a 20-year-old. And I've heard this story, and I think it's quite fascinating how you and a group of, I guess it's peers and students, together decided you were going to launch the first student built rocket that could reach space. And one thing that really inspired me from the story, other than you guys did this in your teens and early 20s, was the persistence you had with the Federal Aviation Administration and the resistance that they gave you and the back and forth. If you don't mind just giving us a couple minutes on how you got into that place and what led to, like, where was the spark of inspiration and idea where somebody said, let's build a rocket, let's take it to space?
No, great question. And for me, I entered college thinking I'd work on planes. My dad was a
Yeah.
pilot and he studied military history. He loved planes. So I grew up, we went to air shows, we'd look up and see planes, and he'd challenge me to identify which ones were flying by, then in types. And that's something that I entered USC as an aerospace engineer thinking for, what ended up being, 5 days in school that I would be working in aviation and studying aerospace to work in aviation. And that first Friday of school, so kind of fifth day of my college experience, all the student groups came in to the introduction classes, so my introduction to aerospace class. and presented what they were working on. They were essentially trying to recruit students to work on their projects. And USC's Rocket Propulsion Lab came in then, and they had this beautiful carbon fiber rocket, they were carrying. And they said they were becoming the first student group or trying to become the first student group to fly a rocket to space.
Mm-hmm.
And this was me as a 17-year-old freshman. Then I loved that idea because everyone else, they were, entering a NASA competition to fly, a rocket a mile high and land an egg on a parachute. They were doing a glider contest.
Yeah.
Then where it's like the glider contest for the last 100 years of who can land like the glider the furthest on a football field.
Right.
Then this was someone else's goal and someone else's competition they were framing as far as what would be the limit, what's the extreme. And there was something about that USC Rocket Lab structure then where it was their goal. They weren't chasing someone else's goal, someone else's dream or competition. They had their own idea and they were going for it without someone else telling them what to do or where the limit of it was. And that captivated me. I think it's kind of obvious in retrospect that I was captivated by those kinds of experiences then, but at the time, it was just exciting. It was pushing the limits on an engineering side, and it was a self-set goal by that group that I went to the first group meeting that Friday night. It wasn't a normal first Friday college experience of going to your first frat party. Then it was us in a lab, starting to build a rocket together. I eventually took that group over my junior and senior year, and junior year is when we flew the first attempt. Senior year, the second attempt.
Wow.
Of those. And absolutely amazing experience. And you brought up the government affairs, the regulatory side of it. That was the main constraint by that point was with the group had developed a lot of the knowledge in my first couple of years there for flying vehicles at that level of temperature and pressure range, for developing the propellant and the motors and manufacturing at scale. The biggest challenge during my leadership for the group was the regulatory side of how do you convince the FAA and the Bureau of Land Management, then that controls the ground where we flew those from, to let a bunch of teenagers fly a rocket, higher than most countries have, in the world, than most countries, most commercial companies.
Uh-huh.
And we did so, but it definitely wasn't, to your point, to a lack of effort that resulted in that. It was something that was a very persistent uphill battle that won a lot of respect within the government groups.
I want to talk about that, but I want to talk. I've got a couple questions that lie before that. You said you did your first launch your junior year, I believe, and your second launch your senior year. What years were those, and how high did they go?
See, so we had done more flights before then. I can backtrack a little bit. The first two space shots were my junior and senior year that I mentioned. As a group, we developed vehicles that flew the lowest altitude ones, sort of 20,000 feet, about 4 miles.
Mm-hmm.
Then those are the testings like avionics, certain structural design elements, things that you could test subscale. Then we flew a generation of them to about 60,000 feet. We flew 2 of those, and those were really to hit the temperature and pressure limits. Mm-hmm. We intentionally designed those to demonstrate the same kind of aerodynamic limits that the full vehicle would hit. That's right. Testing like an element at a time. We did a lot of propulsion testing on the ground. So what you call a static fire, where you have a test stand, you test the engines. We blew a fair share of those up, then you refine and refine over that time. It wasn't just waiting for the big space shot. There was a lot of subscale development we did.
Okay.
And those first 2 went up, or the first 2 space shots went up my junior and senior year. The intended altitude for those was about 350,000 feet, which is the formal space, kind of on what you call the von Karman line, where is the limit of space. Then it's hard to tell entirely where the first 2 ended up on peak altitude, because they did have issues during ascent. Then essentially they had a lot of the motor issues you can test on the ground. There's certain motor issues that develop under the big gravity loads and acceleration of flight. And those you really only learn about in flight conditions. So we flew those, had issues with both. They're 0 to Mach 7 in 13 seconds. Okay. So you're going from 0 speed to about a mile per second. Mach 7's a mile a second or so.
Wow.
In 13 seconds. So very aggressive. We got most of the way through those burns of those motors. Then it had issues near burnout. Burnout for those at about 30,000 feet. And then they coast for about 5 minutes up to 300,000 feet. So I assume parts of those got pretty high, but the issues happened at about 30,000 feet on the way up to, 300,000.
What year was that, Ref, when you did that?
Those were in 2013 and 2014.
Okay. And I'm curious about, how supportive was the university? Did you have some professors that think you guys were just absolutely crazy, or was everybody on board? Let's do this. Like, what was that like?
It was a blend. That
Okay.
program's really unique in the sense that it's essentially one of a kind, or at least at the time was one of a kind. You see a couple other college programs now trying to reach that same scale, which has been awesome to see that kind of goal and mission proliferate.
Hmm.
And but at the time it was conflicted because that group started very early. They had a lab advisor, Daniel Irwin. He's the astronautical engineering department chair. And but Dan was intentionally fairly hands off with the group, other than on kind of major areas on procurement or getting financing support from the university. He let the students set the goals, design the vehicles. It wasn't something where you were, let's say, designing to a professor's intent or getting
Yeah.
guidance from a professor. It was intentionally done to train the students to learn and set goals on their own, which I think has shaped. There's four or five, maybe six now companies that have came out of founders, essentially, that have came out of that group and started companies within the
Wow.
space industry. It's an amazing kind of entrepreneurial training ground because of that hands-off experience. But that was, of course, within a university at a juxtaposition with the staff that were much more conservative, that were much more wary of students learning on their own. And that's something where, from my experience, there's been even within certain high schools, middle schools, like the woodshop class I took in middle school is gone now.
Yeah.
And that hands-on training is not supported. The architecture class I took in high school is gone.
Yeah.
Right, like those programs are less and less where there's hands-on experience and training, whether that's because of cost, because of perception of them not being needed anymore in the workforce, or on safety. And that's the biggest one, obviously, the USC group went through, where that group's had no safety issues for their perpetuity. It's all highly trained students training each other in how to look at a situation that is potentially risky, looking at the risks, addressing them with equipment, with operations, with training, whatever it is, and approaching a dangerous situation or potentially dangerous
Yeah.
situation safely. And that's a set of training that I think is very valuable, training and framework that is valuable, whether you're making something on a dangerous machine or you're approaching a business situation
Yeah.
where you look at the risks, you address them, and you approach them strategically in a way where you come out with a good outcome. And I think that level of, I'd almost call it like coddling within academia and within lower education too, and is very dangerous for training of the workforce. Then dangerous in a way where you're telling people to run away from risks rather than evaluate them and approach them.
Yep.
And so I think that level of training is valuable coming out of there, but it definitely is something that is at conflict in a university environment.
Um, did you ever have serious moments of doubt that you guys would ever accomplish that? Or also like times when the team of students broke down and just thought that this was absolutely not going to happen? Or were you young and naive enough to just go with it and never look back?
I think the young and naive was definitely
Plays a good role.
significantly at play, but I don't think in all the years that group's been operating, other than times where that university conflict, and where the administration didn't know what to do with the group or didn't know how to let them kind of safely operate, and kind of being overly protective parents in a sense.
Okay.
And other than red tape from the administration, I don't think there was ever a doubt within the group that it was possible because we had started proving step by step each relevant technology. The FAA regulatory side, we talked about that briefly before, was definitely a big bottleneck. It was probably the first time the group felt something was not in their control.
Yeah.
And where you're facing multiple government entities, anyone that's ever tried to get things done with one government agency, try to get two to agree on a bunch of teenagers doing something that's never been done before.
Right.
Then, the wildest issues like, what is the risk of us landing on the endangered sage grouse, which is a bird that lives up in Black Rock Desert, Nevada? And where it's tuning the landing dispersions, the Monte Carlo dispersions, and standard deviation distributions of where is this thing going to land,
Hmm.
In the case that the outcome is good on the vehicle performance, in the case there's an anomaly, all the different corner cases, all the different wind cases, all the different uncertainties within performance and day of conditions. The questions from the Bureau of Land Management, because their job is to protect that bird, is a question of how do you know you're not going to land on it?
Right.
Then within, 3, 4, 5 standard deviations
Yeah.
of performance.
Yeah.
And how do you prove that you understand the performance well enough? How do you prove that you understand the winds well enough, the day of setup of the launch pad, things like that? That was a daunting task. And that's just one of 100 different things they were watching out for. And questions like if you have an anomaly during flight, you're 3-hour drive from Reno Airport. How do you know you're not going to land debris on the Reno runway?
Yeah.
Very broad, open-ended questions where it's up to you to demonstrate that analytically, simulation, and it did induce a generation of software tool development within that group that demonstrated on a physics and simulation side of simulating the vehicle under all of that uncertainty what would happen to every piece part. Would we hit a bird? The area that is predominantly sage grouse there, how do you understand if you have a chance of landing a piece of debris on a sage grouse? And we had to run those numbers.
How do you do that?
And
Like, I know this is for my simple mind. Like, I'm a business major, but I'm not I'm definitely not an accounting or mathematician. How do you measure that? Like, where do you start?
where do you start? It's fundamental physics. Then we had used historically at that group a set of rocket simulation tools. They're called 6 degree of freedom tools, which is
Okay.
very broadly, you have 3 degrees of freedom laterally. You can move, up sideways and laterally, and 3 degrees of rotation. 3 different kind of body axes you can rotate around.
Okay.
So if you start from that, the tools are called 6 degree of freedom simulation tools because of that. And then you simulate the rocket. Then where you build the physics model for the rocket engine, you build the physics model for how the rocket interacts with the wind, you build the physics model for how things within the vehicle move around as you burn. Propellant, you build the physics model for how the earth is rotating underneath you. You build the physics model for the atmosphere. You build all those stacked together and get them to run in parallel. And if you do that, you should be able to increment the vehicle along, 100th of a second at a time. Then, where you understand the motor, you understand the wind, you understand the aerodynamics, you understand the thermals, you understand, the planet, the inertia, the inertial side of it, and the rotation of the planet. And if you do all of that right, you should be able to simulate the vehicle time step by time step through the entire duration of the flight. And then you start applying uncertainties to that as far as,
Yeah.
okay, you have the day of predicted winds. How much can those vary? How much historical variance is there? How much do they vary throughout the height? Are you flying on a hot day, a cold day, a day with a solar maximum where the atmosphere is at a peak, or a solar minimum where the atmosphere is more compressed? Then as far as how high up does the atmosphere actually extend, because that varies dynamically. So you can predict all of these. You provide kind of statistical variance on each of those of how much do you expect them to vary, what's the standard deviation for all of the different input parameters, and then you start running all those. It's called a Monte Carlo simulation.
Hmm.
Then where you vary all the inputs and you look at the outputs as far as what is your probability of landing, here, what is your probability of landing there? And to the sage grouse example we were talking about, what is the probability that you will land on the region that has a high sage grouse population? There's a specific corner of Black Rock Desert where we were flying those out of that has a sage grouse concentration enough that you'd have to pay attention to it. And it was tuning and designing not only the vehicle and then kind of what you'd call the nominal, the ideal performance case, but all of that variation on top of it and tuning that design and simulation so that you did not have a sufficiently high, it's generally 3 standard deviations then of statistical variance, that within 3 standard deviations of performance, you are not going to land on that stage risk. So it was a lot on a software side, and a lot of that we had to build ourselves. So the previous generation of leadership of that group said that we would never be able to design our own 6 degree of freedom tool. We were using some software originally designed by the Air Force, but
Okay.
that software did not have the fidelity on outputs to satisfy the FAA. That was the biggest FAA and the Bureau of Land Management. We had to design our own tools in order to do that. And that was something on a physics and mathematical simulation side had been absolutely unheard of within, a student group before.
Wow. Did you guys get to keep that technology, or does the school get that technology, or what happens to it?
It's school IP. The
Yeah.
university has it. The group since then, I wrote the original simulation code that we used for satisfying the FAA. The group had historically written some of their own simulation code, but not at the level of fidelity you could run a full Monte Carlo analysis like that.
Hmm.
So the code that I had written was the first that satisfied the FAA and Bureau of Land Management on restrictions, which is why we ended up flying, my first year there. But the group has continued. It's been exciting to watch to innovate and develop that software further, much higher performance versions, much more accurate versions. And that's all student built, but within the university.
Yeah. So after university, fascinating story, by the way. I think that's so impressive. After university, I know you went to work for SpaceX for a few years. Probably got an incredible amount of learning and knowledge from that experience, and then went on to start Relativity Space. And you co-founded it, and that is where you guys decided to 3D print rockets and aerospace vehicles, and eventually launched the first 3D printed rocket. So I like moments of inspiration because I'm always thinking about moments of inspiration for myself, whether it's going on long walks or meditation or high performance techniques or biohacking or whatever people are using, to find this. Do you remember the moment of inspiration that made you decide to create this company and start 3D printing rockets?
I remember, maybe not the exact minute, but there was a trend of conversations between me and my co-founder there, Tim, who still runs the company day to day. And we had actually gone to college together at that group, the USC Rocket Propulsion Lab. We had ran
Okay.
that together some of the later years that I was there. But for me, I'd gone from USC and I got a SpaceX internship. Then I was working on the Cargo Dragon system, the propulsion system that's on the spacecraft that flies cargo to the International Space Station. And I had successfully completed that internship, got an offer to go full time at SpaceX. And with that offer, I had planned to go move into a house down in Manhattan Beach here in Los Angeles, then with a bunch of the other interns that were converting. And there was something inside of me that got me some cold feet on sign. And I don't entirely to this day know really. I definitely did not have the insight I was going to be starting a company eventually. But I think it was that inner kind of rebellion in me and lack of structure. I really did not want to be signing a lease that said I was going to be in the same spot for some term. And I was just not ready to be kind of locked down at that level. So I moved back in with my parents up in Pasadena. And Pasadena and Hawthorne, where SpaceX is, are on complete opposite sides of downtown. So
Okay.
driving through LA downtown, not a fun experience. So an hour and a half in traffic each way.
Hmm.
And that gave me, as far as on the route to inspiration, I started doing what I think most adults learn when they start commuting is calling your friends while driving. And that I learned, very quickly at that phase, and I started calling my friends, one of which was Tim, and he was up at Blue Origin, which is Jeff Bezos' space company in Seattle. It was on those drives where, for me, I had started working on the Crew Dragon system at SpaceX, the capsule that takes crew up to the International Space Station. And that capsule has what are the first crew rated 3D printed engines in the industry. 3D printing and metal 3D printing was a fairly novel technology at the time, at least applied in production vehicles. And that gave me an exposure to 3D printing that 3D printing was reaching production readiness. It was something that wasn't just a prototype technology anymore. And that's something I had mentioned to Tim as far as like, isn't it amazing what's happening on the 3D printing side? And he was having a similar experience at Blue Origin working on their crew capsule at the time, and he was designing some of their 3D printed thrusters. And so for us, we started having those conversations of isn't it amazing what's happening with 3D printing, but seeing a very limited adoption. People were printing, one part at a time. And we both saw, perhaps it was our youth and naivety with it of, what if instead of printing one part, you printed everything? And it's not just because there's benefits of printing one part at a time. And it's because most traditional manufacturing, especially in aerospace, it's very slow. It's very tooling heavy. It's very expensive. And there's all these constraints around it. And all those constraints go away when you have the printing. The printing is flexible. You can design things, you can iterate, you can design without tooling, kind of iterating at the speed of software instead of the speed of hardware.
Mm-hmm.
And even if every single 3D printed part was worse at performance than its traditional counterpart, you would be in a spot where the entire factory was flexible. You wouldn't have factories dedicated to single aerospace components. You'd have a factory that could be dynamic and nimble, and you could iterate on a product in a way where you weren't just locked in on one design that perhaps you spent years buying and procuring the tooling for, something
Right.
where there's huge sunk cost in that. You could have every single part perform worse while the entire company performed better, and most likely be on a route, especially if you could iterate on those parts quickly, where the parts ended up themselves better. And that was the insight that we were seeing as we had those conversations, was not just isn't every single piece part that you're printing better than its traditional counterpart. It's you could have every part be worse and the company be better if you design it around 3D printing. And that's something that even to this day, a lot of the industry does not understand about relativity and what we came up with, is that they'll have their critiques on printing, or they'll say, oh, isn't it too expensive to develop printers versus traditional parts? Then it's that the company as a whole has this reinvestment mechanism and iteration mechanism that allows it to move faster and faster. But that's it. All of that started coming together on those drives from Hawthorne to Pasadena and Pasadena to Hawthorne, where Tim and I had the same commute schedule. He was the friend that, answered the phone the most when I would do those calls. And we turned what was an entrance of metal 3D printing into the industry on one single piece part where it made sense, the Super Draco engines on the Crew Dragon capsule, into something that was not just, piece part centric. It was company wide on the influence of the technology.
Yeah. I see the value of that. Roughly how many years did you do that commute?
I did that commute for about 18 months.
Okay. So you're thinking like you have 18 months, you have 3 hours of commuting and talking to friends and catching up and thinking about wild ideas. We had a guy on a podcast once that he came on and he said, a lot of people don't consider thinking work, but I consider thinking my most important work, right? And blocks off huge batches of time, quite often, like 4 hours a day, to where you can just think, and walk and go off into nature, right? And it seems like that was your gestation period when you were spending 3 hours a day driving and thinking and talking and exploring ideas and going down random paths. And in today's busy world, like we don't do that nearly enough. Even myself included, that knows, the value and importance of that. But it is so essential. And even you think about Steve Jobs, who took 10 years off from Apple
Yeah.
forcefully. And he said those were the most important 10 years of his life because he got to, become more grounded, work less, focus on different things, see things outside of his normal working box. So, listeners, if you don't spend time thinking on at least a weekly basis, here's a testimonial with Jordan. Spend as much time as you can thinking and just exploring wild ideas and going down those rabbit holes.
I'd add on to that deep work kind of philosophy is so lost in
Mm,
today's world, where the ability to get away from Slack notifications, text notifications, kind of everything happening in the world is paramount for a lot of reasons, whether it's like mental health or on those really kind of creative nuanced ideas, is that it's that balance between, doing something and then kind of reflecting on how it went in a way that you have a takeaway or a kind of a new piece of inspiration.
yeah.
And I think that for sure happened at Relativity. And then even at times, some of Relativity's technical development, some of the most like constraining bottlenecks we had, where we're just throwing resources at them. And then you separate yourself from them for, 2, 3 days. And then you realize like you have the completely wrong approach and you're hitting the head against the wall.
Uh-huh.
And you come back and it's, you change something on something. I'm generalizing a bit, but the ability to do that then and not just be stuck in constant like notification and email overload, then that's where there's always a lot of true kind of magic that can come out of that.
Right, right. So I know throughout the growth of Relativity, you guys went through a raising money period. And I always like to talk about, some founders have a lot of involvement in raising funds. Some
Mm-hmm.
people are hustling and going out there knocking on doors. Other people let other people do it and outsource that. And sometimes just because the magic of the project or whatever they're working on, they don't have to try that hard at all. And so your process going through that, I think you've raised, or Relativity in totals raised like 1.3 billion as of today, roughly around there. Your first round was 500K, I think, and then you went to like 14 million and 200 million and 500 million and on. What was your role in that? And was it easy? Was it hard? And maybe just explain a bit of the process for people that are listening that are interested in raising money and want to understand the process a bit more and how it worked for you, what worked for you, what didn't work for you.
Yeah, no, great set of questions. So when we hit the ground running in 2015, it was kind of December of 2015 that me and Tim decided we were on enough to something that it made sense to step out of our roles at our previous companies, fully congeal, the idea of Relativity and go fundraise. And we did two things. We applied to Y Combinator, the premier startup incubator in the world, and we emailed Mark Cuban, who, from our experience, Shark Tank, we didn't go on Shark Tank, but, Shark Tank, big startup investor, he had mentioned once, I think, that he was interested in space. And we shot him an email.
Did
And
you
as
have,
far as
did you, have you met him before or were you cold emailing him
cold
or
email, cold email,
really?
I
Where'd
think
you get his email
Tim,
from?
it's fairly public. If you search online, you can track it down. And he's
Ah,
surprisingly, more than I think anyone else of his kind of caliper, open to cold emails. Then it's how some
interesting.
of his best partnerships and ideas have came from, and he doesn't
Wow.
have the like warm intro only bottleneck that a lot of people kind of artificially put on themselves. And so Mark responded. We had a couple rounds of emails and met with his team in LA, and Mark ended up investing, and Y Combinator invested as well.
Mm-hmm.
And so the early days, it was very easy. It was me and Tim. We did the fundraises together like that. And obviously, it got harder step by step on the fundraises, where day one, that was by far the easiest fundraise I've ever seen happen. We just sent two emails and essentially, got some money. Then, but no, from then onwards, we did the fundraises fully together until we brought on a CFO, which was the Series D back in 2020. And so we did the first four financings fully together, and on the road together for essentially every single pitch meeting, every call. I do believe that any founder at a company, they should be able to pitch the company,
Yeah.
and whether they're technical, business, operations, any area, that for them to be a successful leader at the company and for the company to be attractive on an investment side as well, that there should be one person on point for the raises. But as far as telling why is this company captivating, maybe it's a different angle from every founder on what's the captivating part of the story that they highlight. But they should be able to tell that story. And then it sometimes falls flat a little bit if there's only one founder that can do that kind of external facing conversation there. So we did those raises together. Obviously, our day-to-day jobs outside of the raises were very different. Tim predominantly on the sales side, myself on the tech development and product development side at the company. And but we started to hand out that process as far as who would be on point for the raise during 2020 when we brought on our CFO at Relativity. And that was reaching a new level for the company as well, where it was less of a focus on the fundamental story and more on the sales traction, the revenue traction side, because the story and narrative took over to the point that it didn't need to be a founder pitching it. And
Mm-hmm.
as far as with that very deep-rooted vision that leads towards that early fundraising success.
What were some of the biggest lessons you learned, Jordan, regarding kind of your fundraising journey? Some either mistakes you may have made or insights you could give to the listeners to help them if they want to do something similar.
The biggest takeaways I'd say is when you have a really lofty vision, like with what Relativity has, like the vision is still being rolled out kind of day by day on where we see the company going, is to have a balance when you talk to investors. Then is that they can get very lost in what is seems like a narrative or story that'll never happen or is so far out and so forward thinking that you're not going to execute on what it takes to get there.
Mm-hmm.
And that was a balance we had to learn fairly early on, where Relativity saw themselves printing. They saw themselves printing bigger and bigger rockets over time, printing in other industries, the long-term vision, which is what would happen if you land a printer on the moon, on Mars, if you made resources in situ, and instead of sending everything there, you had dynamic manufacturing in a very constrained location, like off planet. We had all of that baked into our thesis on day one. But if we went to investor on day one and said, yeah, we as a company, we want to land a 3D printed rocket on Mars, and that rocket have another printer on it, that we then land that printer and start printing rockets with this printer that landed on a rocket that was just printed on the Earth. It's just this kind of crazy narrative that people get lost in. And instead, what really worked was going and saying, hey, we're going to print this small rocket on day one, and here's the benefits. And not even touch on anything that was more than a couple years out. And because you really have to root that in a way where they have, the incoming investor has confidence that that initial execution will start this hockey stick growth. But they don't really need to know what's 20 years down the road, because they can get lost in that. And it can look like a founder's lost in the long-term vision and kind of pie in the sky, then without having that execution ability. So I'd say it's that balance of, you need that long-term vision for the growth potential, but don't let that lose the ability to tell the story of what happens on day one and how you won and how you secured through. And so that's the first one I'd highlight. And then the second is just persistence and education of investors. Like for Relativity specifically, the reason I say that is a lot of the people that were interested in space investing, that are launch investing specifically, by the point that Relativity started raising in the later rounds, kind of 2016 or so, then everyone had already invested in Rocket Lab. Virgin Orbit had already been spun out. Firefly existed. All the different space launch companies had been essentially started and fundraised. So people who understood the space market in a way where they would do a launch investment, they'd invested in another company already, or they'd been conflicted out. There's so many investors in SpaceX that they weren't going to be investing in another launch company. And so we had to win someone over, not only that didn't know the space market and kind of launcher market, kind of a new investor to the space industry, but we had to win them over on a crazy idea that included developing a 3D printer inside of that space. And that involved a lot of preemptive education, where you talk to an investor and you immediately send them, papers and books and education material, some raw, some digested by us. Then in a way where the investor that was very interested but was not informed then had everything they needed to understand why the company made sense. And that's why you see Relativity's investor base being so strong, despite almost none of them having space experience before Relativity. None of them had done space investments beforehand, because we were able to tell that story and narrative and education so well in the early days. And that's what I'd encourage any founders, no matter how obvious the idea is to you, it's going to make no sense to someone else. And it's one of the blind spots that founders often get trapped in, is where the idea makes perfect sense to them. They have the vision, they can imagine it, they can see every step coming together. But if they can't tell someone who's never been in that industry, if they can't tell that story well on how all of that comes together, it'll fall flat. And that obvious nature to us as founders in all sense can be one of our biggest weaknesses, is because we lose the ability to see how to tell it to someone who's never heard anything about it.
What are some of the things you would recommend, or maybe some of the things you guys did to ensure that there wasn't missing any missing pieces to that story? Because I'm actually experiencing a similar thing now with a project that we're doing. And I understand the vision. My partner understands the vision. We're on the same page with it. We know it has huge potential. But when you communicate it to somebody that's not in the same niche, it's like speaking a different language to them, or it takes a while to make that connection. So was there any things that you say that are essential to bridge those gaps?
There's a couple areas. And the first one I'd highlight is finding a parallel that your audience understands well and retelling that story in a way that is along that parallel. The example I'd give at Relativity is we didn't do initial pitches to most VCs as a space company. We did them as a digital automation company, because so many of those VCs had invested in the same thesis, just outside of space, where that thesis was digitization and automation, but in completely different industries. And we started telling that narrative where this is digitization for an aerospace factory, not 3D printing a rocket. In the 3D printing, we told it a different part in that story. And by doing that, given that, in that kind of middle of 2015 market, so many industries were in the middle of a digital transformation on automation, on workforce, on access to the customer. And that if we said that in a way where this is actually piggybacking off that, and they start with something that's native to them, they don't reject the idea. You tell someone it's a space company and they say, oh, I've never done space. You tell them it's a digital automation company. They said, oh, I've made a great 100 set of investments there.
Mm.
And they want to listen and they kind of connect with it. So that would be, I'd say, the general area where it's really trying to figure out what is it that your audience is going to be receptive to, and then reshaping the narrative in something that they're willing to listen to, rather than something that is so novel or foreign to them that they end up rejecting it before they even hear it. And that's probably the biggest like kind of highlight and takeaway in generalities from that fundraising experience.
I'd like to talk about your problem solving process or method that you use. And I don't know if you've ever even considered or analyzed this yourself, but when you have problems or dilemmas or decisions you need to make, do you have a process or something you do or a routine even or ritual that helps you break through that barrier and solve those problems?
It's a good question. I don't have a formal process, and you probably can tell I'm less into formal processes and structure than most.
Mm-hmm.
And but one of the things that I think the engineering background in me was very apt to, both on now the investment side, the relativity side, even my earlier development work at SpaceX and USC, then is applying that kind of engineering process and essentially like driving down assumptions. And that's really on like a debugging side to take that angle. We'd run into an issue on a test stand at Relativity. We'd run into an issue with, developing simulation for the FAA back at USC, whatever it was. And starting to understand and drill down where are there assumptions that are trapping you.
Mm-hmm.
Then where is it that you think you understand something well, but you actually don't? And you're assuming that something's behaving correctly in, let's say, in a system. But that assumption's wrong. Like, where are those blind spots? Where are those assumptions? Where is it something that, your training, your background is making you think something's working when it's actually not? And trying to break things down that way, I think I have a natural inclination, probably it's my rebellion there, is to push back against those assumptions. Then and dive a little deeper. That is like, you have an issue on the test stand. You said this system was behaving correctly, so it can't be the problem. How do you actually know that's the problem? Or not a problem? What is it that's, if you're getting a good signal from a sensor, you think you are, like, what if that sensor is misbehaving and it's a false signal? Stuff like that, where you can dive in. But I think it's a natural kind of Socratic method set of questioning through something of like, how do you know your assumptions right? Right? Why are you making an assumption that is perhaps making you think that you're in a bottleneck or an impassable situation? And can you break down that assumption in a way that you realize there's actually something to break through?
You consider yourself a rocket scientist?
I at least formally, my degree is in the aerospace engineering side, and I did have a propulsion focus, and so I do root a lot in that. But it's been I consider myself kind of a retired engineer in a way that I don't day to day do that much hands-on design or engineering, but that skill set, I think that engineering background is so applicable. You see people from engineering going into business, finance, legal. They're some of the strongest kind of hybrid backgrounds out there because it's such a strong kind of foundational structure on thinking through things.
And it all started from Legos, man. Get your kids Legos. Right. Get your kids Legos. I asked that question because I'm super curious. Like, and I've never met anybody like you before. I've met a lot of smart, intelligent, successful entrepreneurs, but you're very unique, which is a compliment.
Thank you.
What would you say your greatest fear is, Jordan?
Greatest fear. I'd say the greatest fear, and I don't even know if I actually have this anymore. So I think I found kind of my niche and my lane. But my greatest fear, I'd say, would be my skill set not being utilized well. I think I enjoy what I do. I think I've came to realize that I do have a very unique set of skill sets and combination of skill sets that is very rare. And that I'd say for a while, like anxiety on those not being applied. And that's part of even for, my transition out of Relativity. I started to feel less and less at home in the later years where I like tinkering at a fairly like low level, but in a way that's very, business applied. It's how do you turn a novel idea into a business?
Right.
then and kind of apply and scale that. It's like a tool building where it's like the business is a tool for kind of scaling a certain, feature or product and things like that. So I the tinkering's both on the business and like the technical side. And it was those middle years at Relativity where I felt at times I was just fated to be a middle manager. Because I was at that level. Everyone passes through that. You're a founder on day one, you're a C-level on day one, but you're the only engineer. You're not really acting at a C-level. You're acting as a founder, not a C-level executive. And then you go through those kind of those scaling areas where you go from being the only engineer to then leading a small team of engineers to then managing managers. And then eventually you're managing directors and managing VPs and managing other C-level folk. Then there was the middle years there where like my day-to-day legitimately, other than on like the fundraising side, was actually at the middle manager level. Like you always pass through that. And that is, I think I've came to realize for me, I like the high level of the strategic direction, the novel idea implementation. I love the tinkering. And I hate that middle manager phase of growth. Then, because for me, I felt that my entire life was, going through, Gantt charts, budgets, program, like kind of program management level work. And that I very much came to realize is not for me.
Yeah.
And that's where I felt that fear the most, which was I wasn't, trying to implement new ideas. I wasn't executing on the technical work developed like directly. I was literally, micro optimizing Gantt charts and program plans and tracking to make sure that our growth was on track on, the rocket development at the time for Relativity. And I felt a very strong frustration there and where that fear was. But I will say now, like, I've executed on a couple projects that I've worked on some of the most amazing hardware in the world, kind of the most amazing projects in the world. I'm 30 now, or 30. I'm 30 now. That's about as I was forgetting for a second. But I turned 30 in November. Then that at least for me, like I've worked on those projects and found kind of a lane, especially on the investment side for me, kind of post Relativity, where I get to work with founders on day one, then help support them, support their growth. Then in a way that's the phase of company and idea that I really love working on. How do you turn a cool idea into a company? Then
Right.
and develop both simultaneously. And at this point, I'd say I'm fairly not in a way where I'm lazy, but I'm satisfied. Like that fear of finding kind of my place and way to apply my skills has been satisfied.
What would you say was the most offbeat advice that you followed?
Offbeat advice. Um, It's a really good question. I'm trying to think. I'll start with a piece and of offbeat advice not following, then that I'd at least say. And one thing that I'd highlight is, and it was actually a good piece of advice. And at the time, but I had a resistance to it. Me and Tim had a resistance to it. So I'd mentioned me and Tim being in Y Combinator, this
Yeah.
premier Silicon Valley startup incubator. Then extremely good track record there of software companies coming out. And YC over the years has scaled and scaled their software program, and because it's worked. And they've occasionally had a couple hardware companies in. And that's something where those hardware companies, and I've talked to a lot of them, I advised some of them, invested in some of them since, Relativity's days there. And what I'd give them on guidance is that YC gives an amazing set of advice. But you as a founder, you're the only one that understands your company the best. Then no one else understands it well, especially if they're giving blanket advice to 100 companies, 200 companies at a time. And so in this looping back to your question, as far as what kind of not to listen to in a sense, then on offbeat advice is that like you're going to hear everyone's opinion on what to do, on how to build your company, what makes sense to do. And a lot of that is good advice to listen to, but to always view it through the lens that you're the only one that understands your company the best. Because if some cookie cutter advice applies to you, then you're probably not doing something truly unique, or you're not understanding the unique nature of what you're doing. And that's probably where we heard multiple things during YC that we started to resist in a way that we started listening to at times. I remember me and Tim being frantic in some early days. We'd get a piece of advice from a YC partner and start, running like a chicken with her head cut off, trying to like completely revamp company milestones and priority. And then, 24, 48 hours later, we were like, this makes no sense
Yeah.
to be doing. Like, why are we doing this? And I like to give that advice to everyone to make sure that they realize they have to apply that lens and not get in like an autopilot trying to listen to other people's opinions.
I love that you said that. I was in a mastermind once, and everybody goes around the loop and gives suggestions based on the problem that I shared. And four different people gave four different solutions, right? And
Yeah.
then the fifth person said, Chris, like when you ask five different entrepreneurs for advice on something, you're going to get five different replies on what they think you should do,
Right.
right? And there's a great story with Muhammad Ali. Somebody was interviewing him after a fight, and they said, Ali, how come you weren't listening to your coach? He was telling you to do this and this and this. And he said, because I'm the champ. He goes, my coach is great, but I'm the champion. I'm the one that won the Olympics. I'm the one that wins all these fights. And sometimes I'm the one that knows what to do, right?
Right.
And it takes, I think, like skill, experience, and maturity to be able to break away from our coaches and mentors and the people we look up to and not listen to their advice because of maybe an inherent feeling or an analyzation or just a knowing, because we are the creators of this baby that we've created, and we need to follow that sometimes, even when the most authoritative advice says no, you need to do it this way. Sometimes we just have to flat out break through that. And the reason why I asked you is because I think this is in alignment with what you guys are doing with Embedded Ventures now, which you're investing into companies in a very unique way. And so I kind of set you up with that question to kind of bring you into telling about what you're doing with Embedded Ventures and how it's different from most venture capitalist funds that are out there.
Yeah, with Embedded, it's myself and Jenna Bryant, who's the other general partner and co-founder here. She's the one that actually started Embedded back in 2020. And as I was trying to figure out my life in 2020, I had mentioned kind of feeling less and less at home at Relativity. When we had an amazing couple years where I felt my skill set was used dramatically well in developing the company. And in the later years, I was really craving that 0 to 1 experience again of turning an idea into a company. Because Relativity, by that point, we developed the printers, we were scaling the printer production, the rockets were well underway in development, and we were hiring a lot of the world's experts and experienced executives in developing rockets in a way that the rocket program was in good hands. The printers were developed. We were hiring, kind of VP after VP of, seasoned industry experience. And I felt the company was in good hands, and we laid an amazing foundation that led to commercial success, government sales success, fundraising success. Jenna, I had met through an event series she was hosting. She was a partner at another fund here in Los Angeles, an event series bringing together founders that had experience working with the U.S. government, which I had done since essentially college and that original government affairs experience at USC. And DoD innovation leaders were the other half of that event. Then to talk, before it was, the common talk of today, kind of the American dynamism movement and investment movement, but to talk on what the future of DoD venture collaboration looked like. And amazing event series. She had reached out to me originally on LinkedIn to join in, and she had catered such a open conversation that was not having elsewhere. She was able to create a kind of an open ecosystem and environment that people were comfortable talking nitty gritty on what were the real bottlenecks of that ecosystem. I went to her afterwards and kind of asked her, how did she curate this in a way where that naturally came out? Because so many of those events end up being just talking heads and the same talking head points and not really moving the needle forward. Her and I became industry friends through that. And as I stepped out of Relativity in 2020, she asked me first to become a advisor at this new fund she was starting in Embedded Ventures. And for me, that was a way to kick my tires and get to know companies in a way that I could help shape what I was going to do next. And she noticed before I did, and eventually led her to ask me to come on full time as a co-founder and GP, general partner at the fund, was that I loved that early stage experience, then that 0 to 1 moment, in a way that if I was a partner at the fund, evaluating companies, investing in companies, supporting companies through their growth, I would be stuck at that phase for perpetuity in a way that would avoid kind of the champagne problem of Relativity of growing the company past the phase where I really enjoyed it, then enjoyed the day to day. So she was the one that gave me that light that I would enjoy the investment side. And I eventually joined in. She says it took a lot of effort. I said yes very quickly. I think reality is somewhere between there
Mm-hmm.
of kind of pulling me into the fun side. But no, we've built embedded for about 3 years. It's approaching 3 years since that moment back in 2020. Then we invest in national security, space technology, and adjacent areas to that. Me and her, the two GPs, grown the team quite a bit since then. But we have a very heavy technical and operator experience between us and then our fund advisors. And that's something that I found very lacking when we were fundraising at Relativity. I'd hinted at that a little bit earlier, where you see a lot of software founders go into investing. You don't see a lot of hardware founders go into the investment side, then especially space hardware investors. And that's something that as we see the space investment community move from what is investing in launch technologies, companies like SpaceX, Relativity, and others, then to investing in what happens as that launch cost drops so dramatically and new areas in space open up economically, that have never been touched before, or disrupt new areas or disrupt old areas, that have incumbent technologies, incumbent business approaches that are ripe for disruption as those economics shift underneath them. That who's going to be evaluating? Is it going to be the same people that barely touched the launch industry and couldn't think of how the launch industry was going to be revamped?
Mm-hmm.
Or should it be a set of people that have an actual operator experience and vision for the industry that is unlike what the rest of the investment community looks at?
Jordan, do you have one book that you would recommend that most people haven't read?
I do actually. One of
Nice.
my favorite books, and the only one that I actually found reminiscent or relevant to what it took to build, especially a hardware company, something where you have hardware risk, financing risk, market risk, supply chain risk, everything in the world can go wrong, especially to a space and rocket company. And it's not kind of the limited areas that, are behind SaaS or software as a service. And it's building a better mouse. It's the story of
Mm.
building Disney World. And
Yeah.
and I found a lot of reminiscent areas in there, whether it's, the kind of the grand design of building something so elaborate. Then whether it's a business, a piece of technology, all of that combined together into what is Disney World, but building that in the middle of a swamp, then with nothing going right when you're using like cutting edge automation and electronics and things like that. I found it just very reminiscent of building something from scratch where everything can go wrong at once. And there's so many startup books out there where it's like, this is how to build a company. And, the question I'd ask them is, how do they know? How do
Right.
they know that's how to do it? But actually building Disney World and the challenges of that, I just found by far the most relevant, what I call like startup experience book I'd ever read.
Wow.
And so that I'd encourage. And then a lot of people have read it, but Paul Graham's blog, Paul Graham's the original Y Combinator founder,
Mm-hmm.
and highest quality set of writing out there, publicly available. It's free on his website on how to build a company, positioning in the market, management growth. Between the two of those, I'd say it's everything you ever need.
Beautiful. I'm gonna go get those right now, actually. Um, and then where do you see yourself in 10 years, Jordan?
Where do I see myself in 10 years? So at this point, the fund has hit a really good stride, then with embedded, then strong series of portfolio companies. We spun one company out of the fund 2 years ago, and a company called KittyCAD. It's next generation API infrastructure for developing hardware design tools. So think kind of the tools of the day-to-day engineer of how do we bring those, the day-to-day design engineer, how do we bring those into the modern world? They're a couple decades behind, arguably.
Mm-hmm.
So I run that day to day as executive chairman. I was CEO for 18 months or so, and then we promoted one of the other co-founders to CEO. And so I split my time right now, 50% dedicated as a general partner to the fund, 50% to KittyCAD's growth. So I have a pretty strong day-to-day presence within the company still. In 10 years, I believe both of those will be still going strong. Embedded, we're slowly growing our portfolio and assets under management as the fund grows. We'd like to stick to our swim lanes as a fund, as far as where we have asymmetrically good ability to evaluate companies. Then there's a lot of shiny things in venture, a lot of shiny startups, but we really try to stick with what we think we're uniquely qualified to evaluate, then better than the rest of the industry. And I think we'll be sticking with that. Embedded will be cruising along and growing in that same manner. KittyCat's a 2-year-old company now. And just finished our seed round a couple months ago. Then 14 people at the company. I think in a couple years, if not 10 years, then amazing entrance into the design industry. I think that's something that I like spending a lot of time on, which is the day-to-day toolkit of the design engineer. With Relativity, we revamped the design floor. With Relativity, we revamped the manufacturing floor. How do you digitize and automate manufacturing? But the one thing we were not able to solve was how you digitize and automate the design process. So introduce things like machine learning to hardware design, completely untouched today. Then how do you bring automation of the hardware design workflow rather than an engineer pointing and clicking on a screen, 12 hours a day? How do you make that so that's some code running and keeping the design engineer the creative force, but let the computer actually help you in designing that rather than you just drawing lines on a screen all day? And so I think, that's where the majority of my time in the next decade. It's a big company we're building with KittyCat as far as where we see the company going. Huge amount of effort that's going into what that future toolkit looks like in a way that will bring that industry forward. Our goal is 30 or 40 years in one chunk there.
I've got a list of what I call billion-dollar success stories that I've gotten from your podcast here, and we'll revisit those real quick. Persistence, when you guys found resistance with the FAA and continued to pursue to launch your rocket as students. Then a very abundant thinking and naivety, where you guys were still young enough to not think there were any restrictions to do that. Also here, you have kind of like a 10-year vision, what you're going to be doing 10 years out from now. And I think that's essential. You gave yourself time to think on your commutes and drive to come up with big ideas and talk with people that were like in alignment with that. You've got unique books that you read. And I think the best one, for me at least, is don't always listen to your advisors and mentors because you're the one that has to run the show. Jordan, this has been a great podcast, man. I've really enjoyed it. If the listeners want to reach out, and also if anybody's interested in aligning with you or supporting you guys in any way or pitching you an idea for a possible business, where's the best place that they can do that, or how can they do that?
You can find me on LinkedIn. You can find me on Twitter. I see DMs on both that I get back to quite a bit. And then my personal email is on my LinkedIn as well. It's jordan@embedded.ventures. But always excited to hear. It's something that for me, I kind of came up through the industry with people helping me for any or no reason. People responding to me, like Mark Cuban as an example there of just cold outreach is really successful. That's how me and Jenna met as well, who's my fund co-founder. Now that I take a look at all of that, I don't believe in the warm intro only paradigm that is unfortunately significantly common in venture, where you have to know someone's friend in order to find them. The best ideas, I think, come out of network, and it prevents some of that echo chamber from forming. So always excited to hear and reach out to me in any of those 3 forms.
Yeah, and I can be a testament to that. The vast majority of people I've gotten on the podcast was from cold outreach as well. So everybody's within reach in today's world. And Jordan, I really appreciate your time, man. It's been a fantastic interview. And we'll wrap up there. Thank you so much for coming on the show. Thank you for sharing all your tips and tricks and wisdom. I really appreciate it.
Of course. Thank you, Chris.
And listeners, thank you guys for tuning in once again. And we'll see you on the next episode. Goodbye, everybody.